A jogger accelerates constantly to a velocity of 2.3 meters per second in 5.5 seconds after jogging 11 meters. The jogger stops. What was the initial velocity of the jogger? Okay. So, final velocity is 2.3 meters per second. Our time is 5.5 seconds. And our delta x is 11 meters. Okay, 11 meters. What was the initial velocity of the jogger? Okay, we don't know the acceleration and we don't know the original velocity. Okay, so what's the final velocity of the jogger? We can do this in a couple ways. We can do this one. Delta x equals 1/2 Vf plus Vi multiplied by delta t. And that one seems pretty reasonable. We have a Vf, we know a delta x, and we know a delta time, so our only unknown is Vi. So let's go ahead and do that one. 11 meters equals 1/2, and our Vf is 2.3 meters per second, plus whatever Vi is, multiplied by our delta time, 5.5 seconds. Okay, and if we divide both sides by 1/2, 5.5 seconds, we end up with, I think it's 4. Yeah, so 4 equals 2.3 plus Vi. Subtract 2.3 from both sides, and Vi is equal to 1.7 meters per second. That's pretty straightforward. Quentin, you only have the initial velocity as 0 when it says that the initial velocity is 0. So I'm not sure I understand the question. Can you rephrase this question so that the initial velocity would be 0, because I get confused when the initial velocity is 0. Now, that's actually more difficult than you might think, because I'd have to change all the numbers. Because if we just indicated right off the bat that the initial velocity was 0 instead of some other number, then if we didn't change the time, we would have to change the distance. Yeah, no, that was L. We would have to change the distance that was covered over that same period of time. So just changing it to 0 might actually lead to a problem that can't be solved without changing the other stuff. And I don't want to make any mistakes like that. But yeah, so that's how you would solve that one. Would y'all be, I mean, the other way you could solve it would be if you solved for time. If you solve for so it would say the initial velocity is 0. Again, I'd have to change too much about the problem. And again, it would only say that the initial velocity, it would say from rest or from a standing start or some other version of that. It wouldn't, yeah, we did divide the whole thing, including the 2.3 plus Vi. We divided both sides by 1/2, 5.5, and that gets rid of this half and this 5.5, and 11 meters divided by 1/2 of 5.5 is 4, because 5.5 is half of 11 and so on. But yeah, and so since the 2.3 plus Vi is in the parentheses, whenever we divided both sides by it, it left 2.3 plus Vi all by itself and open. And then we were able to subtract from both sides. Okay. We were able able to subtract from both sides like we did down here, and that gave us our VI is equal to 1.7. Okay. So, okay, like I said, it's okay if the novelty of this is wearing out, but yeah, as a result, since this one is so lean right now, I'm gonna go ahead and bounce. My voice still hurts. So any equation that fit this would work. You know what? Let's try to do it with one other equation. Right. Okay. So let's see what we could do with VF squared equals VI plus 2A delta X. Okay. So VF is this 2.3 squared equals VI, which we don't know, plus 2A delta X. Okay, so we actually don't know enough to use this one at all because we don't know acceleration yet. Starting over. Okay, so actually that one is the only one that'll work for that, because all the rest would have acceleration and the final velocity in them, right? Because VF is in that delta V and we don't know acceleration. Again, we don't know VI and we don't know, this one is the one we used, and we do know VF, we do know delta X in time, but we don't know VI. That's why this one did work. This one again doesn't work because we don't know the initial velocity and we don't know the acceleration yet. Will there be graphing on the test? Absolutely, Naya. Lots of graphing. We have, for the review that starts tomorrow for the test, there is a whole station that is nothing but graphing. What if there was another equation but it missed one information, like it wasn't there? Well, just like we did in class today, just because it uses different information doesn't mean that it's wrong. But if it has missing information, like if it has so much missing information that there's more than one unknown in it, then you can't use that equation by itself. You would need more information in order to be able to use that, so that you could use it. Does that answer your question? So you could use V equals delta, or Vx equals delta X over T. No. Again, because you're looking for VI, you have VF and VI in this equation, or in this problem. You know that there's an initial velocity and you know there's a final velocity. So using this way would necessarily mean that the V equals X over T could not work. Okay, V equals X over T is an average velocity, or it assumes a constant velocity, and because you don't have a constant velocity in this problem, there's no way to use it for that. But yes, you can use any equation that has enough space for everything and uses it all up, right? Because, like, let's see, if you did do V equals X over T, you have your 11 meters divided by 5.5 seconds, and that would just give you 2. Like, what does it mean? Like, does it mean that the initial is 2? I mean, it means the average would be 2. Okay, Quentin, see, now I'm worried that you're trying to make the math fit into something that it's just not going to fit into very well. don't get wrapped around the idea that the initial velocity is 0. I'm really reluctant to just load you down with extra rules. So like whenever this is a thing, then this is a thing. Like I really don't like to do that because those rules are really tough to remember and they're really tough to keep straight in your mind. So they're not terribly useful for that in that regard, because the only thing that's going to help is delta V is VF minus VI. Initial average velocity is total distance or total displacement divided by total time. That's what that is. So yeah, like I said, I'm really reluctant to give you a laundry list of if this then then, if this then then, because we've already given you all the equations which are useful in a wide variety of scenarios. And of course the only important thing is that you have enough information to use a given equation, but also that you are using an equation that can tell you what you want to know. And you're right, Brian, a constant velocity does equal 0 acceleration. But we're in constant acceleration now, so no more constant velocities really. But welcome back, X-Curve Speedy. X-Curve Expedy. Anyway, so like I said, I'm really reluctant to give you those, to like just give you more. If you do this, then you do this, because like the equations kind of speak for themselves a little bit. So like the reason I used this equation is because we were looking for VI. We were trying to solve for initial velocity. And so what I needed was an equation. Chili pepper this Thursday. This guy right here. This is a Carolina Reaper pepper. Couldn't find any ghost chili, so I bought one that was even hotter. Anyway, so the reason I used this equation was because legendary name, I don't know why, but now. Well, do you mean my name is, you mean my Fortnite physics name is legendary? But it's actually a thing that I've experienced a great deal, is that coming back to this material after some time, months, years, actually allows me to really understand it quite a bit more. Studies show that your brain takes a little while to process information. It's kind of unpleasant that you have to deal with it so quickly during school. But if you were to come back to this 6 weeks, 10 weeks, a month, a year later, then you would experience that it was simpler the second time around. But anyway, let's keep talking about this guy. Okay, so the reason I picked this equation for this one is that we had a VF and we had a VF and an initial velocity, and we were looking for initial velocity, but we also had time, and a delta x. So I needed all of those things in my equation, right? Like I knew I had those pieces to work with, so I wanted them all in my equation, and I knew I was searching for a VI. So I knew the equation had to include VI so that I could actually use it to calculate. Okay? So the one that gave me the most of that stuff was this one that I've got right in front of me. That's the one that gives me the most of that stuff. But is there a total time and total displacement, so you find delta V? Yeah, I mean, no, not delta V. Not delta V. You could find average V, and that's it. So, Quentin, yeah, if you did total x over total time, all you get is the average velocity. And to prove it, so we have our 2.3 as our final velocity, and we have our 1.7 as our initial velocity, and if we divide those by 2, we get 2 again. And there actually is a way to get from this to this using the average, but it's way too complicated and it's not terribly useful, so I'm not going to bother to teach it. Cool. Does everybody like my subscriber emotes? I spent a little time on Adobe Photoshop to make those. Okay. Like I said, guys, my I remember delta t equals x over t. I don't understand, Quentin. How do you get delta v? Vf minus vi. And acceleration multiplied by time. Both of those things are true. I promise I have a better light for my face cam for Fortnite. But yeah, those are the two to find delta v. Yeah, that's not an equation. Delta v average velocity equals total x divided by total time, or an instantaneous one for some smaller section of it. But no, you can't find delta v that way. Yep. Good. Alright. Okay, guys, my voice is still pretty shredded, especially from talking all day. I'm doing my best to get all your grading taken care of, and we have a review thing going on tomorrow in class. It's going to be a stations exercise, and it'll take up all day tomorrow and some of Thursday, and we'll do a little more stuff. Here's your last chance to ask me a question.